For this grid-in problem, we're told that a sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded in $250 or $750 amounts, and if at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of $250 bonuses? So we can see from this that it's going to be kind of a system of equations type problem where you set up the equations based on the word problem, right? So you see that I wrote down this. Why did I write that down? Because the first thing that we're given that a total of $3,000 were spent, and this $3,000 is composed of $250 and $750 bonuses. So in this case, X is the number of $250 bonuses, and Y is the number of $750 bonuses. So why does this make sense? Because $250 times the number of those bonuses will give us the total number of dollars spent on the 250 bonuses, plus kind of the same thing for the 750 bonuses, and that will give us our total amount spent, which we know is 3,000. We're also told again that the number of each bonus is larger than or equal to 1. We don't know how many total bonuses were handed out, and we're actually looking for one possible number of $250 bonuses. So let's just start by let's just take this top equation right here. Let me rewrite it. So 250x plus 750y equals 3,000. I see that everything here is divisible by 250. Let's just do that. Let's just make it a little easier on ourselves. Let's just divide the whole thing by 250. We'd get just x, right, plus 3y is equal to 12. So let's now, again, we're looking for x. Like, we don't actually define the total amount. We just need just x. So let's solve for x, right? Let's just subtract 3y on both sides here. So x is equal to 12 minus 3y. So again, what does this equation tell us? It tells us that the number, right? We had said that x is the number of $250 bonuses is equal to 12 minus 3 times the number of $750 bonuses. So from here, you can there's a few ways you can figure it out, but I mean, you know that y can't be less than 1, right? So just plug in 1 for y. What's 1 for y? So x is equal to 12 minus 1 for y, so just 12 minus 3, which is 9. That's one possible number of $250 bonuses, right? And if you want, you can work it out. You can do 9 times 250 plus 1 times 750. It'll be 3,000. You can also do x equals what? 12 minus, what if there were two y's? What if there were 2 of these big bonuses? Then it would be 12 minus 3 times 2, right? That's possible. You would get 12 minus 6, right? 12 minus 6 equals 6. This is also a possibility. What if there were 3 big bonuses? You would do x equals 12 minus 3 times 3. Again, I'm just plugging different y's into right here. Because we're just saying, what if there were 3 $750 bonuses? You would get 12 minus 9, which is equal to 3. Now, the question is, what if we move on to 4? What if we say that x equals 12 minus 3 times, what if there were 4 big bonuses times 4? That would be 12 minus 12 equal 0. Can we have that? No, we can't have that because we're told that there has to be at least one of each. So this one doesn't actually work out. So the answer to the problem, you can either bubble in 9, 6, or 3. Each one of these answers is a correct number of possible $250 bonuses.